This episode is brought to you by WeatherGuard Lightning Tech. At WeatherGuard, we make lightning protection easy. If your wind turbines are due for maintenance or repairs, install our Strike Tape Retrofit LPS upgrade at the same time. A Strike Tape installation is the quick, easy solution that provides a dramatic, long-lasting boost to the factory lightning protection system. Forward-thinking wind site owners install Strike Tape today to increase uptime tomorrow. Learn more in the show notes of today's podcast. Welcome back. I'm Dan Blewett.
I'm Alan Hall.
And I'm Rosemary Barnes.
And this is the UPTIME podcast, bringing you the latest in wind energy tech, news, and policy. All right, welcome back to the UPTIME podcast. I'm your co-host, Dan Blewett. On today's show, big list of topics to discuss. Number one, community ownership of offshore wind farms. Is this possible? So, interesting company called Ripple is one of a few different companies on the web who are starting to try to break up essentially commodities, if that's the right word, into where you can buy shares of them. There's another company that's doing this with artwork. So if you want to buy a share of a Picasso, essentially, you could do that. And this is kind of the same concept. So we'll talk about that. It's an interesting idea. We'll also talk about this new Spanish gas tax. There's a lot of issues with natural gas and the price of it overseas right now and how that's going to affect the wind industry. There's also an interesting story about the Ocotillo wind farm. It looks like it was a pretty rushed sort of project, had a lot of controversy, a lot of native people in the area who were opposed to it, and it's been having some consistent problems and it's currently shut down. So we'll talk about some of the implications there. We'll chat about leading edge erosion. There's a new article about a small company getting some funding out of Scotland and raising some questions here about, what does leading edge erosion look like right now? What's the current state of these fixes and solutions and kind of where are we headed? We'll also talk about Siemens Gamesa's 5X platform, how they've upgraded that. And lastly, we'll talk about the Romotion Camera, which is a pretty cool piece of technology to take photos of wind turbine blades while the wind turbine is still operating and rotating at a high speed. So before we get going, I want to remind you to subscribe to UPTIME Tech News, which you'll find in the podcast show notes or description if you're watching here on YouTube. That's just our weekly update email where you'll get an email of the new episode, helpful links, all the other stuff around the web if you want to stay up with wind energy news. And be sure to subscribe to Rosemary Barnes' awesome Engineering with Rosie channel, which is here on YouTube. And we have a sponsored live stream with her a couple times a month, so check that out. A lot of good stuff coming out of Rosemary's YouTube channel. So let's start here with Ripple Energy. It looks like they're a UK-based company. And essentially, if you go on their website, it just says it's pretty straightforward. I think they do a good job of explaining what they do, which is that, hey, you can reserve a share of our next wind farm project. So they're, buying wind farm projects, and then you can buy a piece of it and help to offset your own costs. So this is sort of that community ownership model. So Rosemary, I'll throw this to you first. Does this seem like the future, or does this seem like this is only something that's going to fit select people?
I'm not sure about the future. It's definitely the past. When I was living in Denmark, it's pretty common there, or at least it was back when the wind industry was maybe a bit more small scale, a bit less about, building wind farms with hundreds of turbines. And I actually had a friend, a colleague at my old job who was on the board of his local community wind turbine. It was just one single turbine. And they got to, be in charge of the operating and the manufacturing schedule and stuff like that. And, they could even climb up and have a look and tweak the settings. And it was very profitable as well because turbines that were installed like a decade or more ago in Denmark actually had really generous tariffs. So I thought that was super cool, and I was desperate to get involved in something like that. But all the shares have already been snapped up long ago in Denmark. We have one community wind farm in Australia, in Victoria. I was actually supposed to visit to do a climb and make a video on it, but the pandemic stopped that for a while. But that one started because some developers wanted to make a wind farm in the area, met with a lot of community opposition. And then this one local guy was like, this is a shame. I'm going to drum up community support. And then in the end, they managed to raise what was it? Yeah, $9.8 million dollars raised from 2,000 cooperative members to put up 2 wind turbines. And that was, I think it was installed in about 2010 or something like that. And it's been going ever since, but we've only got that one. So then this new one where it's, Ripple seems to have a bigger wind farm and now they're talking offshore. It's a bit harder to see how it's not like that old kind of community involvement where you really feel like you own it. Like, I don't think just because you've bought shares in an offshore wind farm, you're really going to feel like that's my wind turbine that I own, 1,000th of. So I like it. And I mean, I just because I love wind energy so much, I would buy shares in something like that if I could. I think the payback period was something like 12 years or something, which is a bit more than what you would get for rooftop solar in Australia. So probably makes more sense in the UK where that's probably a decent payback for, a way that you can get involved in renewable energy on a personal level.
That's a good point, because obviously, like I'll give you an example. My parents have solar panels on top of their house. Like, they got approached by a company a long time ago, said, hey, based on where your house is and how much sun you guys get, like, you'd be a great candidate for this. Would you want to do it? And they've done it. And it's really lowered their utility costs a lot. That's a pretty common story, obviously. But yeah, that's a good point. I mean, these shares in a wind farm might make less sense and might have a longer payback period than solar. So, I mean, Alan, how does this strike you? You're more of our business guy here on the podcast. Does this seem like this is a viable thing, or does this sort of like, I don't know, more fluff than substance?
It's a real thing, and we've done it in America a number of different places and times. Most of the electricity generation in the States, especially if you talk about the Midwest and heading through Montana, Wyoming, where everything was local, and so it was a local investment to create the local electric company or the local telephone company, for that matter. And I don't think the UK has been that way. So this is a little bit of a different play. When electricity happened in the United Kingdom, it tended to happen like city by city. Like, one of the first cities in the UK that was electrified was Manchester, right? Which is a big industrial city. So it kind of grew from the major cities and spread outwards. And I think it was more of a governmental effort. So it is unique now that the average citizen can now buy a part of a wind turbine, invest in a wind turbine. I think that's the unique part, because UK is not that big of a place compared to America, right? So a lot of it was organized, and the UK has been much more organized than America has been for many hundred years more. So it's a little bit of a different tact, I think, and it may not be that common in the UK, where it is pretty common in a lot of other places of the world. So from a business standpoint, though, I wonder how efficient this is going to be, because in any sort of investment like this, there's only a certain amount of patience that investors will have on return on investment. If it doesn't start returning on investment, the whole thing will sink. And that'll be a problem, because there'll be this asset out in the ocean that no one owns. And that's not a good thing. So I wonder what the downside protection is in something like this. What the upside is: they get a lot of good wind, and they're selling a lot of electricity, and gas prices rise, which means electricity prices rise, and everybody's happy. But if it happens to fall, you could lose your investment. That's your worst case option. And that's where, it's the downside of markets. And you don't really want to do that with an electrical grid, in my opinion. Too much turbulence in the electrical grid is not good for the average citizen.
Yeah, so I mean, with Ripple, it looks like you can invest as little as £25, and you could invest in as much as 120% of your yearly electrical consumption. So this isn't like stocks. It's not like you're investing in the wind farm itself. Like, if the wind farm, goes gangbusters. Like, you're not investing in Ørsted, for example. It's not like you're investing in the overall company. Mm. And it looks like, it's a little unclear, but it looks like Ripple is the digital, like they're the software platform that connects these co-ops with the people who can invest in them. So, like, right. Ripple doesn't actually own the wind farm. A co-op will own the wind farm, and Ripple is sort of supplying like the software solution to connect buyers with them, which makes a lot of sense. Like that makes sense, because a co-op doesn't necessarily want to, get all this technology infrastructure in place to do that. That's the technology that Ripple's providing. Right.
So they're acting like a middleman in an electricity marketplace. Think of it that way.
So, for example, Ripple acts a lot like a property manager for a building. Like, here in DC, there's tons of apartment buildings. the ownership doesn't lease out. Whoever the investors who bought that building and owned it and built it, they don't lease you your apartment. So they're going to handle that off to a property manager, and that's essentially what Ripple does. They're the property manager for this co-op connecting people. So yeah. But you're right. I mean, there's definitely some risks. I mean, nothing is risk free, but it's an interesting new way to invest in this. And one of the things I had mentioned was that kind of a similar thing, which is not quite the same, but this interesting company, Masterworks, this has nothing to do with wind energy, but like Masterworks is another platform. And this just seems like to be a trend in the digital space. Masterworks lets you buy a share. So Masterworks will buy a painting, like a priceless $2 million painting. You can buy a share of it, and then they'll sell that painting later, like 5-10 years from now, trying to get a certain return. So it's just interesting, like the way technology has opened up people to get involved in different things that they could otherwise never afford. Like if you want to own a wind farm, good luck, raising $100 million. But now you can own fractional ownership of lots of different things like paintings, wind energy, et cetera, beyond just the traditional stock market. So I think that's cool. But moving on, let's talk about this Spanish gas tax. So over in Europe, there's a lot of trouble with rising natural gas prices. This is really boosting electricity costs. And so basically in Spain, they're going to impose charges of 40 to 80 euros on wind farms if they don't buy gas and are earning what they call, quote unquote, a windfall profit. So they're basically going to kind of penalize wind farms for, where the natural gas, whenever natural gas exceeds 20 euros per megawatt hour, all the zero carbon electricity producers are going to have to give back excess remuneration. So, Alan, what do you think about this? It seems like a mess. A lot of people are really upset. They said this is going to shut down a lot of wind farms.
Sure, well, because there's no revenue being generated. If the government's just going to come in and take all the added revenue, then they'll just quit. I mean, there is consequences for doing that, and I think it's funny that the government can think like, well, they're making too much money. We know how to use their money better than they do, so we'll just take it. Well, the response for that is like, well, you'll take nothing. We'll just shut it all down and walk home, right? And that, again, it goes back to the consequences. You're playing with real fire here. Like there are people who need that electricity, and Spain historically hasn't been the most reliable in terms of electricity generation. They used to shut down the power, electricity at nighttime in certain big cities. So electricity generation is needed. And if you keep playing around in those marketplaces like that, you're not going to find anybody willing to invest in them or to promote them or to run them. And I think that's the trouble. When the European Union is weird in this situation, I think, Rosemary, because I think the European Union would poo-poo this, right? They would think this is not right. But I guess the Spanish government is saying like they can do whatever they want to. Does that make sense right now?
Well, I'm not an economist at all, but it seems weird that they've got a big problem with gas supply. And so, that's causing the price of electricity to go up because there's, not enough generators. So they take the one group of people who have invested in something that is, increasing reliability and punishing them for having invested in something that they clearly desperately need to diversify their operations. So, or their generation sources. So I think it's really weird from that point of view. And I doubt that they're not going to go so far that people are going to start shutting wind farms, because obviously that's just going to exacerbate their problem much worse and make the government look very, very bad and hurt the people that rely on the electricity. So I'm sure they'll sort it out. But it is it's really weird. It's hard to understand what they're even trying to get at in this aspect. So I'm going to wait and see how it plays out, because it can't end here like this.
I mean, is this like a bailout, Alan? Is that a way to liken this, or am I off there?
No, I don't think so. I think there's just been a lot of governments in the EU, Greece being one of them, Spain being another, there's Italy being another, that financially has really been hurting before COVID happened, from the last economic downturn. So now that COVID's happened, a lot of the industrial parts of large countries have been shut down. So therefore tax revenues drop. Therefore you can't afford to do the things that the state wants to do. So they're going to start going after any points of revenue and providing and creating these little tax takebacks, they're going to take back from the quote unquote wealthy and distribute it to whoever they feel like, I guess. But that doesn't make things better. It just exacerbates the problems you already have and can put economies in really big tailspins here. So they're really playing, in my opinion, they're playing with fire. Like, you don't want, in a fragile economy situation, to start just randomly taxing corporations, because corporations are smart. Business people are smart. They see that happen to one industry. They think, well, it can happen to me also. So here's what I'm going to do to protect myself. That's not good, right? And so the bigger picture is, some of these countries got to, figure out their economic conditions and figure out how to survive. And this is not a good way to go historically.
Well, it looks like there's going to be a legal challenge. The Renewables Association, APA, is threatening to take the government to court. But I don't know. I mean, is the rest of the world as litigious as America? Like, in America, if there's anything you don't like, just go ahead and sue them for like the next 5 years and just tie it up in court. I don't know. I mean, Rosemary, obviously you're not in Spain, but do you know much about these legal challenges in the rest of the world?
I think I've noticed Australia is getting more that way recently. We've got like a whole spate of politicians, especially, that are suing.
Don't let us rub off on you. Don't let us do it.
Yeah, they're like suing people for saying something mean on Twitter. Like a politician sues someone for something crazy like that, and there's a YouTuber getting sued. I actually got a little bit scared and got legal advice because I don't want to be sued by any politician. So in Australia, we're getting more that way. Although I think the businesses have always sued to maintain their rights. So it doesn't surprise me that businesses would do that everywhere, even if in general the country isn't as litigious. I mean, it would be very harmful to the industry. You can't just change the rules so that any time that times are good that you don't make any money. I mean, wind farms and solar farms as well. They've got variable pricing, and they rely on those really high periods of high prices to make up for the times when there's low prices. So I think it's easy to say, oh yeah, they're raking it in right now, but when you look over the the lifetime of a wind farm, there's going to be good times and bad times, and you need both to make the business case stack up. So I think it will be a huge shame if it goes ahead, and I'll be incredibly surprised if they do something that would ruin that, because the renewables industry is huge for Spain. They benefit a lot from it. So, I think it'll work itself out, but it's a weird announcement that that they've chosen to, be so antagonistic.
Yeah, I mean, it definitely, if this was in the U.S., there'd be so many legal challenges already floated out there. So the fact that this is threatening, makes sense. Like, if I was a business in Spain, yeah, this would be something you definitely get the lawyers involved with, because it's potentially going to have a major impact if not shut you down. So that makes sense. But yeah, we'll keep an eye on this. And this is a great time to just remind you all that Rosemary supports all politicians equally and unequivocally. She loves all politicians. So just put that under your thumb. All right, moving on. So over in California, there's a farm, the Ocotillo wind farm. This is it looks like maybe an hour and a half due east of San Diego, pretty close to the Mexico border. But this has been a controversial wind farm from the beginning. They've had a couple wind turbines throw blades. They've had one recently collapse. And this was not without controversy in general from the beginning. And now the fact they've had they've had reoccurrences of incidents, like major safety incidents over and over, where now finally the wind farm is shut down, at least temporarily. It's not permanently closed, but the feds essentially are moving in and figuring out what's been going on, because I guess in the past, an entire blade was thrown, near a place where there's maybe foot traffic, and there's just been a lot of the concerns, I guess, that were voiced. Of course, many communities voice concerns to new wind farms. Some of them are founded, some of them are not. But in this one, it seems like a lot of the concerns, were well founded. Alan, what was your take on this situation in Ocotillo? And it seems a little bit out of the ordinary that this would be shut down like this, but then again, it seems like they have had a lot of problems.
They have, and I don't know if it's particularly unusual, but I think it gets down to, was there some workmanship issues, whether there's some installation foibles that happen, or is it just the environment that the wind turbines are in or causing additional problems that they hadn't envisioned from the design standpoint? I don't think anybody really has a handle on that yet. And lately, what we've noticed is more of a tendency to shut down all the turbines in a particular wind farm site and to get the engineers back on site to figure out what's happening, to have a plan of attack, and to also communicate that to the local community. I think that's probably been one of the better moves that the wind turbine operators have done lately, is when they've had issues like we've seen in Iowa recently, where they had some wind turbine blades break off from, looks like lightning issues. They really took the lead on it. I thought the operators there took the lead on it and also made sure everybody understood what was going on. They started shutting down some of the turbines. This all makes sense, and I think it's the right thing to do, because what your worst case situation in these sort of failure events is, the local community just completely loses faith and really starts driving the politicians to shut it down. And I know the current vice president was actually involved in some early litigation with this wind farm site and decided that she had a conflict of interest and didn't essentially do anything. But they have connections to start reaching out to politicians and could shut this thing down. In California, anything can happen any moment. That's one thing you know about California. So I'm a little concerned about the engineering side of it, and probably Rosemary can talk a little bit more about the engineering side of the wind turbine. But I think politically and just sort of the communication is getting better, and that's a good thing.
Yeah, do you remember it was a few weeks ago we talked about another American wind farm that was just decrepit, falling apart. And with that one,
Oklahoma.
I remember, yeah, and it was some manufacturer that doesn't exist anymore. And I was like, okay, so their design just wasn't up to scratch, and that's why they went bankrupt. But these ones, Siemens Gamesa turbines, I don't know for sure, but I'm assuming that there are thousands of the exact same turbine installed without problem elsewhere in the world. So it makes it a bit more interesting. And when I read a few articles on this, and it seems like there's been some allegations of fraud with the developers. I know that they misrepresented the wind speed, and they don't make as much energy as was, promised. So that's a financial issue, but should make the engineering job easier. I mean, they should be less loaded. So I don't know what's going on, but it's really strange that, this one wind farm full of Siemens Gamesa turbines is, unsound, whereas all the other ones that are installed around the world, I mean, you're not hearing if there are a lot of wind farms with this turbine falling apart to the extent that this one has, where it's multiple turbines. I think like 2 towers have buckled and blades have been thrown, including one onto a track. I mean, we would have heard about that, and it'd be a big problem for the company. So I think, we've got to look politically and as well for the real cause of this.
Well, this is in the desert. So if you look this up on Google Maps, like I have, it's like, and that's what I don't quite, I guess, as much. I mean, obviously there could be vocal opponents in any place, but this is not really like an inhabitable area. Like, this is smack in the middle of the desert. It's not that far from the closest town is El Centro, but this is on the outskirts of town. This is on desert land, kind of like between the mountains. So yeah, there's some highways that run through it and maybe a trail or two, but otherwise this isn't like really in people's backyards, is at least the way it looks like on the map. But I mean, Rosemary, do you think it's just the temperature? I mean, this is legitimate desert here. So is it just maybe the brutal heat and wind? But obviously wind is not a problem. But I mean,
because it's saying there's less wind than there should have been. Maybe, or I wondered if maybe they're not being maintained correctly, or if there was some dodgy installation happen, or something that would mean that this wind farm and not the other wind farms that use the same turbine are having that problem. Yeah. There's plenty of turbines in deserts, and there's issues. It's hard. The sand is abrasive, but it doesn't sound like that's a really obvious cause for the specific problems that they're having.
Well, Rosemary, what causes the wind turbine blade to hit the tower? Like, how do you get that to occur and to have the tower essentially fall over from that?
Well, I think the most obvious way is when the blade structure gets damaged in some way, so that when it loads, it bends more than it should. I couldn't say why. Often it happens from a lightning strike, which I'm sure you're familiar with.
Yeah.
I mean, for it to happen one time, okay, yeah, it could be a manufacturing fault. If it was a serial defect with all of these types of turbines, you'd see it a lot elsewhere. It's, nearly 10 years old now. It's not like, I just can't see how you could have so many issues with one farm and none elsewhere. So it's weird.
Does the blade pitch drive that? Like, so if the pitch of a particular blade got decoupled or was commanded or had some sort of hydraulic issue where it was positioned incorrectly, wouldn't that be able to drive the blade into the tower? Just a pitch issue?
Yeah, for sure. I mean, when wind speeds get high, they have to start reducing the power output so that the generator can keep up. And if that didn't happen, then you might see at a high wind speed too much load on the blade and it could, bend and hit the tower. So I guess that's a possibility. Yeah, for sure.
Yeah, I never thought about that before. So I guess they're going to shut it down and do a root cause analysis and really get to the bottom of this. But I think that's a good point, that these are Siemens Gamesa turbines that are successful, well-engineered turbines that are doing fine most other places. So the question is, you're right, why are they doing so poorly here? And what's the variable at play? So moving on, we're going to talk about leading edge erosion a little bit. So there's an interesting story from renews.biz, just of a small Scottish company, Edge Solutions. They've gotten some funding recently, €700,000 for their Armor Edge solution for leading edge erosion. Now, we've talked about leading edge erosion a bunch, and the greater point of today isn't really like this company and what they're doing, because there's a lot of companies that offer leading edge erosion solutions. There's robotic repairs, there's wet repairs, there's these plastic shields that are epoxied on. But Rosemary, like, where is the current state? And this seems kind of weird that they're still throwing money and doing testing. Like, there's a lot of companies that are doing this, but it sounds like leading edge erosion just really isn't solved yet, and that they're still looking for potentially new solutions. Is that kind of the climate of it at the moment? Yeah,
that's right. They're definitely still looking for solutions. There's a wide range of products available that make a big improvement, but definitely the issue isn't solved. And I think it is one of the top major headaches that wind farm developers and operators are experiencing now. I think it's one of those problems that's really, it's hard to imagine why it's so hard to solve. It seems like once you've identified that this is a problem, then you would just fix it and then it would be gone. But it's incredibly difficult to make a material that is going to withstand the conditions that some wind turbines are in. And it's not all wind turbines. I think it's interesting that this is from Scotland, because people always bring up the coast of Scotland as like one of the worst places to install a wind turbine in terms of leading edge erosion. They just have like a lot of rain. The droplet size of the rain is particularly problematic there. Maybe they've got some dust and stuff in there, I'm not sure, but that's a particularly harsh place to try and have a leading edge last for 20, 30 years.
Well, and you've done a lot of leading edge erosion testing on strike tape, your lightning protection tape. Tell me about the droplet size. That's interesting. I don't know that much about it. Is a smaller droplet worse? Is a bigger droplet worse? I mean, is there something in the middle?
Yeah, it depends, and that's part of the issue. And I think ORE Catapult over in the UK is doing a good bit of extensive research on droplet size and the effect of droplet sizes on leading edge erosion, which is a very fascinating topic because it also has applications in other areas like aircraft. I think in the last 2 or 3 years, we know more about leading edge erosion and sort of the dynamics of why a water droplet can be so catastrophically damaging to something that's pretty rugged otherwise, right? Wind turbines are pretty rugged things. The fiberglass epoxy systems are pretty rugged. So how can a droplet of water actually do that much damage? And it has to do with how the water droplet hits the surface and then kind of reflects. There's a kind of a shock wave that comes backwards. And in that shock wave tends to want to rip things apart at a microscopic level. So it isn't like one water droplet wipes out a whole leading edge. It's the repetitive nature of that. It's sort of like a sandblasting effect with water. So in our experiments, and we've done a lot of rain erosion testing at our facility, and the water droplet size plays into it really heavily. Angle of attack, how the water droplet hits the surface, plays into it a great deal. So what we're seeing right now, I think, is trying to develop some standards around it and then prove it out in service. And I think what we're finding is our first cut at it about 5 years ago in terms of rain erosion testing, and what we thought worked is now been out in service 4 or 5 years. And we're finding like it works in most places, but not all. And that's why OR eCatapult's stepping in to provide some more technical leadership there. The latest one, I think this is interesting, and I think Rosemary will think it's interesting too, which is they're talking about using essentially what an airplane uses, which is a sort of a hardened nickel leading edge. Like on helicopter, rotor blades use this sort of hardened metal as the leading edge to protect the leading edge. That's one of the solutions they're talking about for wind turbines. And I know you looked at heating wind turbines, and I thought, well, you put a piece of metal out there, how well is it going to go icing wise? And it just introduces a lot of complexity than just leading edge erosion, wouldn't it?
Well, I'd be most worried about the lightning protection of the system then. If you've got something conductive, then you have to make sure that it can handle a lightning strike, and you know that the path of the lightning follows a non-damaging route, as I'm sure you're intimately aware of all those challenges. It also just sounds like it doesn't fit the manufacturing process too well of a wind turbine blade. I mean, you'd be making a pretty precision-made part to get the right shape, and then you have to make sure, I mean, every wind turbine blade is not the exact same shape because there is a fair amount of hand finishing. So I think that would be more complicated than it sounds. I actually did hear a couple of years ago about some interesting directions that they're going with, you know, technologies to get around this, not surfaces, but actually detection and controls. So there were identifying what types of rain cause the erosion, because it's not like all rain causes erosion. There's certain types of rain that really cause a massive amount of damage in a short amount of time, and then the rest is okay. So if you can identify what those periods are and maybe slow down the turbine a bit during those conditions, then you can potentially, just for a small hit in, you know, it's not very long that you have to reduce your output and save a lot of damage that way. I haven't followed up on how that's going, but I did at the time a couple of years ago think that sounded like a promising path.
So is it more like the heaviness of the rain, like a really big downpour, like really big droplet size, or was it something like there's frogs in it? Like what are we talking? What are we talking here?
I haven't seen anyone test for frogs specifically. But yeah, I think heavy rain, and if it's dirty, there can be like little bits of dust in there. I think that's bad. I've seen someone researching hail. At least some people think that hail causes bigger problems, but I know other people think it doesn't. So, yeah, I'm not totally up to date on exactly where that is. Maybe Alan is more current on that.
Alan, how does the atmospheric conditions, how do they interact with rain? So if it's like really dusty outside, or it's just you're in a kind of a windy, you know, like desert environment, I mean, I assume that every time it rains, it's sort of collecting that dust inside it as it goes.
Right.
Is that, is that how it works?
Yeah. If you notice on your car, when it rains, that your car gets dirty because there's dirt in the water, so to speak. So it's not pure water falling from the sky in any sense, right? And that does add to it a little bit. I think what OR eCatapult and some of the researchers up in Denmark have been looking at, really focused on the last year or so, is something called the acoustic impedance of the leading edge protection. So it kind of falls into my world, which is like antennas and RF stuff and crazy electrical stuff, where you have a shock wave that's hit the leading edge, and you want to just let that wave move forward and not get reflected back. It's in the reflection back that everything gets torn apart. So if you can keep the acoustic impedance of your materials pretty stable and kind of shock absorbery. Is that a word? Shock absorbery?
Definitely not a word. No
Okay.
No chance it's a word. No.
I think we all know what it means, though, that you want to absorb that energy.
We got it.
Yeah, let it absorb the energy in and not have it reflected back and try to tear everything apart. So acoustic impedance is like something that people who make like AirPods think about, or high-end speakers think about. It's not something that we typically think about on a wind turbine or an airplane or anything else that gets hit by the rain. So it's kind of a new area. There's not a lot of data about it, but that's where the technology and where the research is being focused at is on this acoustic impedance bit. So we'll see what comes out of it. It's interesting. We've dabbled in it a little bit, but there's just some really serious research going on in that area right now.
So last question. So Rosemary, obviously you talked about it being really difficult to put like if the nickel leading edge was a solution that was viable, it'd be really difficult to do that. But in general, why are all these secondary companies these doing retrofits? Like why don't factories just make better leading edges is my question.
Well, they do. I mean, every manufacturer has a leading edge protection product, whether it's a surface that they own, a proprietary surface, or if it's something that they're bringing in from, like 3M has a wind tape product, which is probably, I don't know, the default standard. And not everyone orders it. You know, it costs more. Some wind farms have a lot of problems with leading edge erosion. Some don't. Into new areas where they don't know yet that they're going to have a problem with leading edge erosion. So you can order a product, it adds cost, or you can order the blade without a protection and add your own, or you might have done, the modeling and have a estimate that the amount that you would have to add in maintenance is less than the amount that it would cost to install the leading edge protection, so they choose not to. So definitely, everyone has a product available. Some are better than others. Some have, some have better reputations than others in the industry. But it's definitely an area that a lot of smart people are paying a lot of attention to, and companies are spending a lot of money trying to come up with better solutions. So at the end of the day, it's a hard problem to solve, harder than it sounds like it should be.
So Siemens Gamesa, speaking of, they have upgraded their 5X platform, and they have two turbines in this platform, the SG 6.6-155 and the -170, which that number just refers to the meter length, so 155 or 170 meter length blades. And they have a flexible power rating between 5.6 and 6.6 megawatts. So it sounds like they've upgraded these to 6.6. Alan, I mean, when they have these flexible power platforms, what are they waiting for? I mean, is it just new software upgrades coming out, or I mean, why doesn't every platform just have the top rating from the get-go?
Well, it's just because the technology gets better over a 5 to 10 year period, and so the generators get better, the blades get better, gearboxes get better. Everything gets better. Electronics gets better. So, the foundations of the wind turbines, which are the towers and the nacelles, are just a housing unit or support unit. So you can put whatever it will support in there in terms of a generator and also electronic cabinets. So you could dramatically increase the amount of power. Like if you're going from 5 megawatts to 6.5, right? And that's like is that 30% improvement, some crazy number like that? That's a huge step up in terms of energy output. And so you start running the numbers. Well, how much energy can I produce? How much am I selling it for? So what is my return on investment? If I can basically take out this old generator, which is essentially paid for, maybe get something for it on the used market, putting a new generator and recover that investment in a year or two, a lot of people are going to do that. And I think in the United States right now, you're seeing a lot of that upgrading of the generators, the blades, some of the control circuitry and that kind of thing, software, to generate more power with the same platform. That's going to be more of the standard than building new onshore in the U.S. I think it's going to be a lot of reusing what's already there because it's built, and now the permitting goes away, all the complexity goes away, so you can just produce more power. I think that makes a lot of sense. And Rosemary, is that same thing going to happen in other parts of the world too, not just the U.S.? Oh,
well, I mean, I don't think that a wind turbine behaves too differently in the U.S. to how it does somewhere else with similar wind speeds. I mean, I was a bit surprised to see that they're calling it the same platform, and I think that they were calling it their 5.X platform, so it's weird to see a 6.6 megawatt generator in the 5.X platform. And I think normally, I mean, my understanding of how the platforms work is, you're trying to keep as much of the turbine in common as possible to, so you can get your economies of scale and have a lot of turbines produced in the run. and then tweak it so that it suits the conditions. So, the first way they did that was basically you put the same turbine in a lower wind speed area. You got to have longer blades to be able to use the generator that, you would have in a higher wind speed area. So that's pretty normal that you'd have two blade lengths. So the 155 diameter is going to be for a high wind speed area, and then you use the same generator with the 170 meter diameter in a lower wind speed area. So that's all pretty normal. But then to increase the size of the generator, then it means that you're able to capture higher wind speeds, because obviously if you've got a 5.8 megawatt generator at above a certain wind speed, you're not going to be able to get as much power as there's more power available in the wind than what your generator can actually handle. So you upgrade the generator, you can capture more of that. And I mean, it's basically just a big balancing. You've got your LCOE equation, levelized cost of energy. You've got your capital cost, and then you've got the energy that you produce and sell, and you're just trying to balance that so that you overall end up with the lowest cost. So I guess it's just giving more specific options to really precisely suit local conditions. That's my interpretation of it.
So it sounds like maybe kind of the way, like example, Ford Motor Company would use the same frame of a truck as they would on an SUV as well. So they try to reuse parts just to kind of save in manufacturing. Alan, is that a good analogy?
Yeah, it's like if you have an old Mustang and you decide to put a bigger motor in it. It's kind of like that. You're still using a lot of the components of the car, but you have more output. Very similar.
So last on the docket today, the Romotion Camera, which is really cool. And basically this is solving one problem, which is, can we not shut the wind turbine down to take photos of it? Obviously, drone inspections are a huge thing, and like drones are going to be ubiquitous if they're not already ubiquitous. Maybe they're already. Who here votes for drones being ubiquitous already today? Yeah, I mean it's like one of the best applications for it, right? But the Romotion Camera is a ground-based camera. It's got a little track, can drive it around, and then it's going to rotate with the wind turbine. It's going to figure out how fast it's going, adjust itself to sort of rotate with it, so we can take essentially still photos of a full speed rotating wind turbine, which is really cool. It's obviously got a pretty long zoom, and it can just let it keep going and get good photos. Now the question I think is this going to be better than a drone inspection, or is it just going to be something that's going to fit some customers and not others who don't want to have the expense of a big full drone inspection and shut down for a day or two? I don't know, Alan, where do you see this fitting in? Because it definitely seems like it has, a use case, but what customers do you think this is going to be right for?
I think it's going to have to show itself to be less expensive overall to take the images. And the drone's pretty inexpensive, and it can do it fairly quickly. The camera method on the ground, while technically a great accomplishment, I don't know if it can keep up with how fast some of those drones can scan these turbines. The only difference between the two is one's spinning, one's not. So maybe in the shutting down and restarting, there's that time delta there that can kind of even it out, but it doesn't feel like it. And I'm also wondering, it gets down to the expense of the thing. The cameras are and the technology and the high the big lenses that go along with that are not cheap, whereas we're buying these drones for almost nothing today. So the cost is where I think it's just going to choose a winner. There's obviously going to be places where the camera is going to be used because maybe they don't allow drones, like Washington, D.C., right? I mean, there may be places where you can only use a camera on the ground.
There's also no wind turbines in D.C., but yeah, that's a good point.
Not yet.
Right.
Yeah. Right. So it's just going to be a little bit fascinating because I know how hard it is because we're in it, in the wind turbine industry, when you come out with a technology product, how hard it is and how many years you have to grind at it before the industry really accepts it. I'll give you the good example with Ping and Matt Stead. I think he was working on it 7-8 years before it really got going. That's the kind of time frame it takes for the industry to kind of accept you and then bring you into the chain of buying decisions. So I'm wondering, because the drones have got such a head start, whether the drones are going to win out in the end just because of that problem.
Rosemary, what's your take?
Well, I think there is some potential here, and I haven't seen the images that it can take, because I guess that's the thing. I mean, are they like crystal clear like a drone image would be because the blade's still, or are they slightly blurry? If they're slightly blurry, then there's probably not too much potential. But I think they've got several advantages over drones. The first one, obviously, you don't need to shut down. And also it makes scheduling maintenance a little bit hard because you don't want to shut your turbine down if the price, like it's really good wind and the price of electricity is high, then, you don't want to shut down for any reason. So there's that advantage, which is maybe not a huge one. But I think the second thing is that it's taking photos of the blades while they're loaded. So to me, that was a really interesting thing. So I bet that you can see more cracks from a blade that, like a smaller crack would be visible on a blade that's loaded because, you imagine when you bend something that the crack will open up a bit. So I think there'd be that. And also you would be able to see if one of the blades was perhaps bending more than the other ones, more than it should be. You'd be able to see that too. So I think that if those two things, if you really can see that information and it provides an earlier warning signal than the drone inspections, then I think that would be a huge advantage. So I actually think that there's quite a lot of potential here as long as the images are really good quality.
I was watching some video on it because it's super cool technology. Okay, so it's got me hooked when they got some new software camera system. So what it's doing, it's actually taking images along the blade as it rotates, and it's splicing them together with software. That's essentially what it's doing. And the images, obviously what they showed on YouTube, look really good. So my guess is that they've got the imaging software to get in and look at the blade and know where it's looking at also, so that it can splice the image together. So it's a compound image, much like with drones. The drones do the same thing. So it's almost giving you a similar end product. But Rosemary's right. I think on the stress in the blade and looking to see where there may be damage. I'm curious that I've not ever seen a wind turbine where I saw one blade bending more than another, and probably thank God that has. I've never seen that because that sounds scary. But if you did, you would be able to notice it, and that's an interesting piece because you may be able to pick out real structural defects in the blade while watching it move that you wouldn't otherwise pick up, and that's a really interesting thought. And maybe that's where they're headed. Is that this is a blade under stress? Let's look at it there versus being still. That's interesting.
Well, it could be like a bigger piece of the puzzle. So say you do drone inspections of every turbine in your wind farm, and a couple of them have some, like maybe you need dig a little deeper, and then maybe you do take photos while they're under load or something like that. So it could have that. But yeah, it's like I said, I think the key is whether or not they're too late to really compete with drones and the ubiquitous nature of their inspections.
Yeah.
So that's going to do it for today's episode of the Uptime Podcast. Thanks so much for listening. Be sure to subscribe on iTunes, Spotify, Stitcher, YouTube, wherever you're listening or watching. Again, you can sign up for Uptime Tech News, our weekly update on the podcast and news around the web in the show notes below. And be sure to subscribe to Rosemary Barnes' YouTube channel, which you'll find also in the show notes or description. Thanks again. We'll see you next week on the Uptime Wind Energy Podcast. Operating a profitable wind farm is all about mitigating costs, minimizing risks, and being efficient with maintenance, repairs, and upgrades. It's incredibly expensive to send a team of rope access technicians up tower to make even simple repairs. We also know how costly lightning damage can be, requiring inspection, repairs, and downtime for even minor lightning strikes. Maximize the time efficiency of your techs and prevent future lightning damage by installing our Strike Tape LPS upgrade the next time your crews are going up on ropes. Learn more in today's show notes or visit us on the web at weatherguardwind.com.